To kick us off this afternoon, I'd like to introduce you to Tobias, who is Managing Director of SciTech Australia, and he has a few words for us.
Good afternoon, everyone. My name is Tobias. I'm the Managing Director of SciTech. SciTech is excited to support the MedCan Summit, and we're very much looking forward to meeting everyone face-to-face in November when the event will go ahead. We've been in business for 30 years now and have extensive experience in the pharma industry. As a first mover in supply and service of cannabis processing equipment and manufacturing equipment, we've assembled a really good and probably local industry leading experience. Our solutions range from biomass drying and extraction to isolate production and beyond. Most manufacturers we represent have long-standing track records in the pharma industry. We've partnered with selected players on the cannabis-specific equipment side who also have extensive track records and often are widely accepted industry leaders. Most of our equipment is available in GMP versions, which is particularly important whenever we're talking about pharmaceutical products. Our team offers local service competence, including preventative maintenance and calibration services. For customers based in Australia, we can also offer finance options for the equipment we supply. Thank you for the invitation today to contribute to the webinar series, and I hope you find the information Andre will present now very helpful. Thank you.
And thank you for attending today. My name is Andre, and I represent SciTech, a medical cannabis technology company. Again, thanks everyone for taking the time to join the MedCan webinar series today. We're here to review full spectrum cannabis. We will cover what is in this cannabis spectrum, the methods of full spectrum extraction technology, and what efficiencies can be gained with different methods. In closing, we'll discuss the products of today, the products of tomorrow, and what is needed to get us from A to B. Having worked in the cannabis industry for most of my life, I've seen many different marketing terms evolve. The most common of these terms is full spectrum. I've seen this term used in different ways, from full spectrum oil to full spectrum extraction. I've seen broad spectrum cannabis and whole plant extracts. There are even terms such as HTFSE or high terpene full spectrum extract. These terms have been used to describe cannabis products that retain a very robust cannabinoid, terpene, and what could be termed bioactive profile. And we are seeing initial evidence that the entourage effect has more therapeutic value than individual APIs, that the whole of an extract is greater than the sum of the parts. And I've seen various marketing teams run with this concept, yet I haven't seen much explanation for what is actually happening. What is this spectrum, and how are we making use of it? Though complicated, this diagram represents a simplified overview of the secondary metabolite production in cannabis. And we can largely group our bioactive compounds of interest into 6 major categories. We have cannabinoids, terpenes, flavonoids, stilbenoids, alkaloids, and lignanamides or phenolic amides. Now there are 10 major cannabinoid groups, including CBG, THC, CBD, CBC, and many others. And we're beginning to discover more every year, with the most recent discovery by an Italian research team in the beginning of 2020 around THCP and CBDP. Now, there are over 120 terpenes known to cannabis and thousands produced in the plant kingdom. There's over 20 flavonoids discovered, over 19 stilbenoids, over 10 different alkaloids, and 11 lignanamides or phenolic amides. As can be seen, the bioactive spectrum in cannabis is broad, and this spectrum is found in various parts of the plant, from seeds and roots to leaves and flowers. These groups have varying chemical properties, from nonpolar to polar, volatile to non-volatile, and hydrophilic to hydrophobic. And in plants, there's a very wide array of factors that causes these molecules to be formed. Plants, and all of life, exhibit what is called phenotypic plasticity. Based on external stimuli, certain genes are turned on or off, and only if these genes have been passed on from a prior generation. Our phenotypes can be thought of as the observable outcome of genes or combinations of genes. Things like color, height, or growth rate are all factors that can fall into this category. Now, various environmental stimuli can cause and turn on these genes, allowing this system to act as almost a natural security system. Stress factors can be anything from pathogens and pests to fluctuations in cold or heat, or excess or lack thereof of water. In a response, a plant will produce various volatile organic compounds, VOCs, are secondary plant metabolites. And these aid in the plant's survival. These metabolites act as antioxidants, preventing damage from reactive oxygen species, such as oxygen in the atmosphere. They can act as antimicrobial and antifungal agents, or as natural pesticides. And we see this in cannabis, as many terpenes and cannabinoids are found to exhibit these protective properties. Things as simple as where you put your plant in a grow room or how much UV light is exposed to can cause quantitative differences in the amount of VOCs produced by a plant. Our soil content, from heavy metals to salinity, can influence the same factors. In short, the cannabis plant can produce a very full spectrum of compounds, but controlling and standardizing that production into a final product is an extremely difficult task. And this is why we favor breaking down the plant into subsequent parts and recombining those parts on desired therapeutic applications. How we handle our biomass from harvest to how we formulate our final products all present challenges in creating a truly full spectrum product. By harvesting in the morning versus the middle of the day or late afternoon, I can potentially change the quantitative yield of certain compounds. The final product formulation, whether it's a tincture, a soft gel, a tablet, or a vape, all offer a different means of delivering a different portion of this spectrum. And each product can require a different production technique. Our bioactive molecules readily oxidize and undergo degradation when exposed to excessive heat. And to further this difficulty, we largely don't know what molecules are degrading into and when during the process. Today, degradation is commonly quantified by testing for the absence of a molecule we know we began with, not by qualitatively understanding the molecule we know it degrades into. Aspects as simple as the absence of analytical standards for these degradation pathways limit this research. Today, we're going to focus on quite possibly the most important factor, extraction. We'll review 6 primary types of extraction methods: microwave-assisted extraction, or MAE, steam distillation, ethanol extraction, subcritical and supercritical CO2 extraction, hydrocarbon extraction, and what the industry calls solventless extraction. As one of the least common methods, it is important to define solventless extraction. The method starts with a preliminary extraction utilizing freezing cold water, causing trichomes, the cannabis resin glands, to fall into water. We then use micron screens to filter and collect these trichomes, rich in cannabinoids and essential oils. Products are dried and sold as is, or they are taken through a secondary mechanical process by which plant oils and resins are extruded from the plant with pressure and heat. As this is a new extraction technology, there is very limited data on what bioactive molecules this method extracts. The method also has a high risk with API variability in the final product due to the production process. Microwave-assisted extraction utilizes microwaves to heat plant cells from the inside out, causing cells to rupture, releasing bioactive molecules to be extracted more readily. MAE is one of the only methods capable of extracting almost all bioactive molecules due to the ability to introduce and change the solvent matrix. Steam distillation is one of the oldest extraction methods, having been used for thousands of years. It has shown success in extracting terpenes and the essential oils of plants and is commonly used in the beverage and fragrance industries. In my experience, cannabinoids require too high of an extraction temperature for an efficient extraction process without causing degradation. Ethanol extraction is also one of the oldest methods of extraction due to the ease of ethanol production and its great solvating properties. It has been used for botanical extractions in tincture production for centuries and is commonly used in two-phase extraction and multi-step solvent extraction processes. The inherent difficulty with ethanol is the similarity in boiling point with volatile compounds such as terpenes, resulting in the formation of complex azeotropes that are difficult to separate. Subcritical CO2 is proving to be the most efficient, high-throughput terpene extraction method. Cannabinoids, specifically their acidic forms, do not extract as efficiently and require decarboxylation before extraction, co-solvent extraction with ethanol, or extraction in the supercritical range. CO2 has also been shown to be useful in extracting other bioactive compounds, such as flavonoids or alkaloids, but again, with the aid of a co-solvent. Hydrocarbons such as pentane, hexane, and heptane have been used for selective extraction in a wide range of applications, including cannabinoids and alkaloids. Additionally, propane and butane are showing great promise in what the industry calls fresh frozen cannabis extraction, whereby biomass is frozen in the field and extracted using hydrocarbons, preserving the essential oil fraction in its most pure form. Unfortunately, these solvents do not allow selectivity between cannabinoids and terpenes and are more dangerous to work with due to their flammability. We need more data. Some of these methods are great for polar molecules, and some are great for nonpolar. Some require the addition of co-solvents to achieve higher efficiencies or the ability to extract certain components selectively. And each method has its various advantages and disadvantages. Both hydrocarbon and microwave-assisted systems produce one of the highest quality extracts as they can extract fresh biomass. Studies have shown that while essential oil profiles before and after drying are qualitatively the same, quantitatively, there can be between 10 and 30% losses. While microwave-assisted extraction has a very low capex in comparison to other techniques, current GMP systems do not have high throughput when considering very large commercial scale operations. Hydrocarbon extraction is one of the highest throughput methods, but it offers no selectivity in separating cannabinoids from terpenes, which is a necessary step when considering the high temperatures required in many downstream post-processing steps. Steam distillation is an industry standard for natural flavors in the fragrance industry, but the method will not produce as high of a quality extract as other methods due to oxidative and thermal degradation, and it requires the processed biomass to then be dried before extracting the cannabinoids. CO2 offers a high throughput method of extracting dry biomass, but requires a high capex to enter the space. Subcritical CO2 is capable of extracting terpenes, but cannabinoid extraction requires us to decarboxylate the biomass before we extract to ensure an efficient extraction process. Ethanol is capable of a full spectrum extraction, but when we consider the effect of trying to remove the extracted terpenes from ethanol, it is rather difficult to justify the method as full spectrum, as it is not cost effective to remove ethanol from terpenes at larger commercial scales. Not a single method used by itself is capable of producing a full spectrum extract efficiently. Certain technologies require different processing parameters or the addition of more solvents. In light of this, we propose a combination of methods to achieve the highest manufacturing throughput with the highest quality. From an entry-level perspective, we would propose extracting fresh biomass with a microwave-assisted extraction process. The microwaves will partially dry out the biomass and act as a potential sterilization step, a great starting point for downstream processing. From here, we would use vacuum drying technology to remove the remaining moisture before beginning cannabinoid extraction. The cannabinoid extraction would then be performed with cryoethanol, resulting in a high cannabinoid extract within minutes of extraction. This method works well as we extract at temperatures at -40°C, preventing the need for winterization. The final steps are solvent evaporation and oil activation through decarboxylation. A scaled method to this technology would start with freezing the biomass. From this point, we would use freeze-drying technology to remove residual moisture content. Freeze-drying technology is the proven method in many industries to remove water moisture from plant material while leaving the delicate essential oil fraction in place. From this point, we would use subcritical CO2 to extract the terpene fraction. Following, we would use the scaled ethanol extraction skid capable of extracting at -40°C, performing inline filtration, inline solvent evaporation, and inline decarboxylation. To date, we feel this is the most efficient way to process hundreds of kilograms of cannabis per day while retaining the most pure essential oil fractions possible. And now that we have broken cannabis into its subsequent parts, we can begin the process of putting them back together. Product design is the most important factor in this world of full spectrum. There are so many different aspects to consider, from how it's grown to how it's processed. And all of these factors determine what I view as the most important: consistency. Can you make a consistent product, and how can an entry-level consumer approach the use of that product? Cannabis is very well known because it is inherently safe. There has never been a death caused by cannabis consumption, but that does not mean it is easy for everyone to use. THC is psychoactive and tolerance dependent. Consuming too much THC can be a very uncomfortable experience for many users. We also have a variety of THC-based molecules to choose from. We have Delta 8 and Delta 9 THC, which differ by the location of a double bond between carbons 8, 9, and 10. Delta 9 THC being the more psychoactive form. We then have another variety of THC-based molecules. This is THCV, THC, and THCP, who differ by 2 carbons each in the alkyl tail of each molecule. It is theorized that when increasing the length of this tail chain, we increase the psychoactivity of the drug. And then we have the metabolism of THC. THC readily converts to 11-hydroxy-THC in the liver during first-pass metabolism, which any oral consumption form is subject to. 11-hydroxy-THC is more water-soluble than THC, permeating the blood-brain barrier more readily and can produce a more psychoactive and lethargic effect. This is largely why THC edibles are to be taken with caution. And so far, we've only been discussing THC. What's going on with the remaining 250 bioactive compounds? Monoterpenes are highly unsaturated, meaning they have multiple carbon-carbon double bonds. Now, it's well known that unsaturated carbon-carbon double bonds react with strong acids. So what happens to certain terpenes in a tincture as they pass through your stomach? This is what makes our formulation so important. These molecules all have subtle differences and interactions that lead to large downstream effects. Some of these differences are as simple as having the exact same chemical structure, but differences in stereochemistry. Stereochemistry leads to what are called enantiomers, which are essentially right and left-handed versions of the same molecule. These left or right-hand differences can lead to changes in the perception of smell, such as with the enantiomeric versions of limonene. One hand smells more like oranges, the other hand more like lemons. They're different, but the same. It is well known in the pharmaceutical world that specific enantiomers have better binding affinity for certain receptors and are thus their preferred molecule of choice in creating a final product. Beyond the bioactive molecules, we then have a very wide array of receptors throughout the human body to target. The endocannabinoid system is complex and plays a role in the regulation of everything from sleep to stress to pain. It's how your body maintains homeostasis. Most commonly known are the CB1 and CB2 receptors that both cannabinoids and even specific terpenes have been found to interact with, and there's a wide array of interactions still to be discovered. These receptors are spread throughout the body. It is extremely important to figure out how to deliver your active molecule to the site of interest. And with every delivery form, whether ingested, inhaled, or applied topically, there are a very wide array of factors to consider. In very, very few industries do we have one entity growing the product, extracting the product, manufacturing the product, generating unique IP, owning the distribution channels, and doing the final retail. It's unheard of. In medical markets, the path to the customer is through general practitioners, insurers, and specialized physicians. And what they and the customer want is a consistent product with reliable data at the most competitive price. The end consumer needs to know what is in the product and what components of these products are useful to them. We all need to know what is happening, as there is a multitude of drug-drug interaction occurring between cannabis constituents, what we term as the entourage effect, and between current medication consumers may take. For example, CBD has been found to inhibit certain anti-epileptic medication. CBG has been shown to inhibit some of the anti-nausea properties found in other cannabinoids. We need data to show what is happening so we can make validated label claims and so that we have therapeutically applicable products. To achieve low costs, we need efficient manufacturing. And though manufacturing is one of many cogs in the supply chain, it is where some of the largest costs and largest margin for a business are. Achieving efficiency is of the utmost importance and one of the largest areas we can reduce costs for the end consumer. At the end of the day, we want cost-effective solutions for the millions, if not billions of individuals who can benefit from the wide therapeutic actions of cannabis. The products of today are serving that purpose, and the products of tomorrow will be that much better. With full spectrum research, we can achieve full spectrum products. Thank you for your time. If there's any questions, happy to answer.
Thank you very much. This is Zara Champion. So I'm the Executive Director of Biotech New Zealand, as we saw at the beginning of the presentation. So again, thank you so much, Andre. I feel like I knew a lot about cannabis, and now I feel I know very little. It's incredibly complex, and so it was a fantastic snapshot. Now I see that we don't have any questions at this time, so if anybody has any questions, please can you use the Q&A function and just type in your question. But I have got a number of questions here for you. So what are some of the considerations outside of extraction for processing these compounds?
Oh, absolutely. So largely a lot of the compounds that we're interested in working with are delicate. Delicate meaning they're subject to degradation, whether by oxidation or thermal degradation. And after extraction, we use a wealth of processes that have the potential to subject our extract to temperatures or to even just the air where oxygen is present. For a primary example, decarboxylation usually is performed at temperatures around 120 Celsius. And when not taken into consideration, you can cause certain molecules to evaporate or degrade, such as terpenes. So it's very important to understand very specifically what molecules you're targeting and what's the easiest path to get there.
So, and when you were talking, you showed all the different types of extraction methods. If you're a company, would you end up using all of those extraction methods, or would you sort of stick to one of those methods?
So that's
What's
definitely a
common?
great question. And I think largely it's going to be based off of, again, what you're trying to make, which is the goal with the overarching theme of this presentation, in that you can achieve the production of products in various ways, and there's very specific efficiencies to be gained with each type of method. Personally, I'm a fan of utilizing ethanol and CO2 extraction, as it gives me the widest range of kind of production capabilities when selecting final products, which I think is pretty important, as most cannabis businesses in this space find they need to be dynamic. They don't know what they need necessarily a year from now, as the market's constantly evolving. And I think those two technologies specifically really allow individuals to be agile with how they react to market demand.
And so in New Zealand, do we have, because like in the food sector, we've got the food bowl, and so they've got bespoke different pieces of equipment, so you can trial and to see how you want to design or how you want to formulate your food product. Is there anywhere in New Zealand that enables you to try different techniques? Like, how would you know as a company which to choose?
So to my knowledge, there's nowhere that you can go about testing these technologies very specifically because of the GMP regulations around some of the equipment, and most all of the equipment that's going to be used throughout these processes. A lot of the extraction equipment is very specific to cannabis itself and has been designed in the US and broader markets very specifically for cannabis. And that's where you see the ability to use other technologies, but they're meant for general food products. They haven't necessarily been designed for use in cannabis. And I think that's where finding a company such as SciTech, who can help walk and educate people about the different ways you can achieve different processes with different methods, really allows you to do that. And I think some of the best places to do it would potentially find reference customers and or labs that are known in the industry that commonly use these pieces of equipment for use.
Right. Now, I've just got a question from somebody. If you were going to use CO2 extraction, what is the post-processing that's required?
So with CO2, you have an ability, and it's one of the good things with CO2, to kind of change temperature and pressure to cause CO2 to act in these different ranges that we call subcritical and supercritical. And as we transition between these two phases, we gain efficiencies in extracting different components: terpenes, cannabinoids, plant waxes, and lipids. And you can think of these as individual kind of bell curves that all overlap with each other. And there's certain regions where we get combinations of molecules or specific molecules. Now, we can collect a fraction of terpenes, but it might have a little bit of cannabinoids or waxes in it. And you then take those terpenes through post-processing, essentially a winterization step. We can then collect a cannabinoid fraction that may be relatively pure, but at a relatively low yield. And you take that fraction through maybe a decarboxylation process. And then you're going to get a large fraction of cannabinoids that have waxes and lipids dissolved in them. And you take those through an inherent winterization process, whereby we're using ethanol in really cold temperatures to cause the waxes and lipids to precipitate. And then we filter those from solution, leaving us a cannabinoid-rich ethanol solution. You then evaporate your solvent and then take the remaining extract through a decarboxylation process as well. And that's kind of, in a brief summary, the different aspects of CO2 processing that you'd consider.
And just picking up something that you mentioned as well, why do you say that hydrocarbons are not scalable as extraction solvent?
Absolutely. So A very large difficulty in working with hydrocarbons is their inherent flammability. And when you work with propane and butane versus, say, hexane or heptane, propane and butane are compressed gases, which then combines a factor of pressure with flammability, making these solvents that much more dangerous. Now, when you work on a small scale, it's fairly not easy, but it's more manageable to deal with those solvents. And as you scale into commercial operations, very large scale operations, the design and CapEx associated with the facility build out and requirements around utilizing these hydrocarbons is a lot more encompassing and a lot more difficult to achieve.
And just another question here is, what are secondary metabolites and or what are the primaries?
Yeah, absolutely. So primary metabolites in plants are often your initial hormones and molecules, such as auxins and cytokinins, which regulate different growth factors inside of a plant. Plants exhibit what are called auxiliary buds or apical meristems, which are regions of a plant that are growing, and they grow because you have a release of auxin in that area, or you have a release of cytokinin in your roots causing root growth. Whereas our secondary plant metabolites are often molecules produced by the plant as a response to some external stimuli. I get attacked by a bug, so I produce a terpene that may cause that bug to be repelled. Or I produce a terpene and smell that causes a pollinator to be attracted to me. Largely, these secondary metabolites are antioxidants because a lot of these processes whereby a plant is attacked by something naturally cause the production of what are called reactive oxygen species. So a lot of our cannabinoids and terpenes have found to be have and exhibit similar antioxidant or anti-inflammatory properties, antifungal, antibacterial, and that's kind of the difference between what you would call a primary metabolite and these secondary metabolites that are largely our primary interest.
Thank you. Now we have got our participants are very quiet today in terms of their question and answer. So if there is no more questions from the group, I think we will leave it there. Now, Andre, remind me, are you coming down to MedCan in November?
Yeah, absolutely. We definitely will plan to attend in November, hoping we're able to travel there at that time.
Fantastic. So you'll be there and you can answer lots of questions, and our participants now have got a good understanding of extraction and can ask you lots of really technical questions.
Absolutely. Happy to speak again, give another talk, and answer any questions that may come about during that time period.
Perfect. Thank you. Thank you so much, Andre. Thank you for your time today, but also your time pulling this presentation together. And I also wanted to thank Tobias as well for your time today. And again, for SciTech for your support for the MedCan conference. Without you guys.